Hello. Today we are going to quickly deploy a web server on EC2 instance in public subnet. And then we will see what could possibly go wrong and how we can secure this infrastructure. So let's get started. Here, let's take a look at the first infrastructure. It's a very simple. We have a VPC, we have a public subnet, and we will deploy an EC2 instance in this subnet and then have it access to internet via internet gateway. All right, let's go. So this is my VPC, and I do have a default VPC here. I have called it demo VPC, and this demo VPC has only one subnet, which is a public subnet. And I can say that because I know that there is a internet gateway attached to it. Yeah, so this subnet is my public subnet. I am quickly going to open EC2 console and launch an instance. So this is going to be my public web server, which is an Amazon instance. I'm gonna take T2 small and keys here. This is my demo VPC. This is my public subnet. Elastic IP is enabled. Security group. I might want to create one security group. I will call it public web server security group, and it is going to allow all traffic. Makes it easily accessible through internet. I'm going to leave SSH and also create like all traffic from internet to the instance. Under advanced details in user data column, I'm going to copy paste my very secure code that you can easily find in my GitHub repository. I'm going to launch this instance and wait for a couple of seconds. So the status is pending for now. Let's wait for another minute. Okay, now the instance is running. Let me copy this IP address and paste it here with HTTP. And there we are. This is my web server up and running. But currently the server is overly permissive. The security group, it does not block anything. It allows SSH, it allows all traffic to go through this uh, instance to the web server. Okay, there is another way to figure this out. What could possibly go wrong, right? Let's go to the console and open a Cloud Shell. A Cloud Shell is like an IDE, and there's a tool called Nmap that is used for pen testing or hacking purposes that would scan the network ports that are open and accessible. And somebody can actually get into your system using this open ports. So I'm going to install this here. And while this is installing, we can run a curl script and use this address and see. So we have most of the information on our fingertips just by looking at the public IP address of this web server. We know when it was created, what kind of a server it is, what version of the server it is, when it was modified. And so, yeah, you could know a lot of vulnerabilities that exist within the server. Uh, so we have installed Nmap in this. Let's take a look at the open ports. So I'm going to use this nmap command for port scanning, and I will use the same IP address and paste it here. Let it scan, and here within like a fraction of second, you know that port 22 is open, so any hacker or any person can SSH into this server and take it down, or maybe escalate privilege and get the root passwords and whatnot. Port 80 is open, 25 is open, and this is not a good sign. This is not a secure architecture at all. So let's secure this infrastructure. And here we're going to implement a two-tier web application where in the same VPC in the public subnet, instead of deploying instances here, we are going to have a load balancer that would redirect the traffic or filter and redirect the traffic to the instances in a private subnet. And to make it, that would not only make it confidential, it will also give high availability because you can create multiple EC2 instances here and redirect it to through the target group. You can also create multiple instances in multiple private subnets and have your application load balancer redirect the traffic to your instances. We have a NAT gateway as well because we are running web servers that might need access to patch or update the server, and so we are going to deploy a NAT gateway as well. Okay, so let's go to the VPC. So under this 10.0.0.0/16, I'm going to create a new subnet and I'm going to call it my public subnet 2 because the load balancer, the application load balancer requires two separate public subnets to be allocated. So if one goes down, it is still active through the other. So this is my public subnet 2. Preference to availability zone. My first one is in US East 1A. Second one should be at least US East 1B, shouldn't be in the same availability zone. That's one of the requirements of the application load balancer. And I'm going to create a unique CIDR, use a unique CIDR here, and create this subnet. Along with this, we are going to need a NAT gateway. So I'm going to create one. This is my NAT gateway. It will reside in one of the public subnets with an elastic IP, and I'm going to create it. And then I'm going to create a private subnet. Wait, this is not yet a public subnet because I need to associate this with the route table here. All right, so I'm going to associate the subnet, edit, add this here, and save association. So now for sure, I know that this VPC has two public subnets connected to Internet Gateway, right? And this has, okay, and then I'm going to go to subnet again and create a private subnet in the same VPC here. I'm going to call it my private subnet, no preference for now, a unique CIDR, which does not overlap with the existing ones. So there, and let's create the subnet. This has to be private, but I do need to connect this to the NAT gateway. Go to route table and subnet, associate the private subnet here, and any traffic to this private subnet that requires internet should go through the NAT gateway, this NAT gateway that we have initialized already. Let's take a look at the VPC now. To public subnet, internet gateway, a private subnet, NAT gateway. Sounds good. Now let's go and create our EC2 instance. So I'm going to launch my private instance. For this lab, I'm creating only one, but you can create as many as you want from here. And let's keep it small. The same in the private subnet here. I don't need a public IP. And we're going to name the security group as private web server security group. So I'm going to leave SSH for now, just in case I need to do any remediation later. And I might just add another rule for HTTP on port 80 from anywhere, but later I'm going to change this to make it more secure. And then under advanced details, I'm again going to use a super secret script that you can easily find on my GitHub repository. I'm going to launch this instance for now and wait for it to be active. Meanwhile, I can stop this public server that I'm not going to use anymore. And okay, so this is running and we do not have a public IP address because it is a secured web server, right? And we do have a private IP. One way to access this is through SSH because we have left SSH open for now. But to make it access through web, we are going to use application load balancer. Okay, so let's go here and look for load balancers. And let's create a load balancer. Here I have three options. I'm going to pick application for now because this is a web application. I'll call it my ALB. It is internet facing and let's keep it this way. Keep the demo VPC. The two subnets are the public subnets. Okay. And security group. Let's create a security group for this one. I'll call it ALB security group. Allows only HTTP for now. In this VPC here, add an inbound rule, which is HTTP traffic from anywhere, and so is the outbound. Let's create it. And now let's go back to the load balancer. Reload it here. And yeah, I have this ALB security group. I'm going to remove the default security group and I'm going to create a target group now. Target group to target on the instance or instances that we create. Target group name is, this is my ALB target group, goes HTTP 80 from demo VPC. Looks fine for now. And I'm going to select my private instance, include this as pending, and create this target group. Create and then go back to the application load balancer, creating console, and let's take a look. Yes, we have this target group, and I think we are ready to create it. It will take some time to provision. And while it is taking its sweet time, let's go to the private instance security group here and maybe edit the rule here. I am going to add a rule where I'm going to allow HTTP from the security group of my load balancer only. I don't need HTTP from everywhere for now, and I'm going to save this. I will remove the SSH rule as well to make it more secure, but I might need that or I can Yeah, I can use my Bastion host security group to make it secure. Yeah. Okay, so it took me around 4 minutes to got my application load balancer status active. It looks good. Let's take a look at the target group. One instance, which is healthy. It's a good sign. Let's go to the ALB and copy this DNS name into a new browser. And there we have our protected web server up and running. And remember, we have reached out to this instance via application load balancer, right? Because the security group only allows this, the source is the security group of ALB. I can safely remove my SSH now as my server is running and save rules. And I could still have my server healthy, right? Now let's go back to the Cloud Shell and make sure that this instance is private. So first thing first, here in details, we do not have a public IP, which is itself tells that this is not accessible through a public IP address. If I copy the private IP address and then paste it here in my curl command, or maybe nmap first to see the open ports, it will keep loading without any result because the private IP is only accessible within the VPC, and internet or people around internet or hackers, bad guys cannot really access the open port, cannot scan those open ports. And the same goes for the curl command. Let's try that. We could do HTTPS too, but it will keep like that in the loop without changing because it cannot access the private IP. And so is the nmap here. That. So we can save that our instance is secure. But there is a lot more that we can do here. We can have an HTTP connection to it using certificates. We can have a like CloudFront or WAF and have Shield to protect it from DDoS attacks. And we will leave that for the next time. As for now, we have learned that misconfigurations in AWS don't always throw errors. It sometimes just stay there silently and leave your infrastructure wide open. And this is what I have learned by making some mistakes, but yes, I have learned to secure the infrastructure. And I hope you find this video helpful. Thank you.